Okay, everyone, welcome to OWASP London chapter meetup. We are live streaming at the moment at YouTube, so people watching us online from all over the world can also join us and ask questions and watch all the presentations. Tonight's meetup is kindly hosted by Civotech Junction, which is this wonderful venue, and the food and drink is sponsored by Endo Labs. For those of you who don't know me, my name is Stepanyan. I'm one of the OWASP London chapter leaders. We have two other co-leaders who are unfortunately unwell today, so they didn't come, Andra and Sharif. If you are going to tweet or put anything on social media like LinkedIn or any other social media about this event, please do tag us using hashtag OWASP London, and you can mention us using OWASP London. We are OWASP London on all the platforms. A quick reminder of the code of conduct. We are a very friendly community, so everyone is very nice. So please make sure that this is a comfortable and welcoming community and it stays like that. And if you have any issues, please do come and talk to us. Please be nice and respectful to each other. Agenda tonight is I'm going to do an intro and update you on some of the OWASP conferences which are coming up and projects. Then we're going to have Henrik speak about attacks on open source supply chain and how the hackers poison the well. Then we're going to have a networking break so you can have some more pizza and beer. And also please do help yourselves to some swag on the swag table. We should have lots of stickers from different supporters of OWASP. And then after the break, we're going to have Brenden talking about OWASP SocialOSINTLM project. So it's a brand new project created by Brenden, which is quite an interesting tool written in Python. Also, we'll have a Q&A session. And then we're going to have Richard talk about how to use LLMs to accelerate threat detection. So, hey, we do have a bit of AI, right? No meetup these days goes without an AI-related talk. But then we're going to have an after party. We're all going to go to the pub. And just before we go to the pub, we also have a raffle prize giving. So I will tell you what the raffle prize is in a minute. So how many people are here for the first time? By the show of hands. Wow, so many. Thank you very much for finding us. I have no idea how you found us, but this is the way to find us, because we have a webpage on mainowas.org/London. We're also on Twitter or X. We are on Facebook. We are on Meetup. We are on YouTube. We are on LinkedIn, Eventbrite, and Blue Sky, and also on Slack. If you want a Slack invite, you can just go to owasp.org/Slack/invite and enter your email address, and you will join our Slack community, which is quite good and busy as well. And here is the prize for tonight. That's going to be this awesome lightsaber, because we're in the month of May. So may the force be with you. To enter the raffle draw, you need to scan this QR code, because this is only valid for people currently present in person here in the audience, right? So sorry, people watching us live on YouTube, you cannot claim this prize. It will only go to the person who is it, and the way how we will identify it, I'm going to get the list of names when you register, and I hope every single one of you got a sticker label with a name badge, so we will make sure we give the prize to the correct person. I will display the QR code throughout the event, again, and obviously during the break as well, so you could register with our sponsor and get a chance to win this awesome lightsaber. I'm going to try to play this OWASP introductory video. The audio on this sometimes doesn't work, so let me see if it works this time. It doesn't, right? Okay, so I will then switch the audio and do something else. 1 second. I will try to play through my laptop speaker instead. Instead of the HDMI. And see if we can get some sound this way.
OWASP is a nonprofit that stands for the Open Web Application Security Project. OWASP is a community of developers, technologists, and evangelists improving the security of software through tools and resources. OWASP has 100+ active projects, and new project applications are submitted weekly. Projects are open source and are built by a community of volunteers. people just like you, community and networking. There are hundreds of local chapters worldwide and thousands of members. Meetings are free and open to everyone. They include training, talks, and networking opportunities, education and training. OWASP hosts many events each year. They are a great way to improve your skills, build your professional network, and learn about new trends in the industry. One of the many ways you can get involved is to become a member. The membership benefits include discounts for events and trainings, your own OWASP email address and Google Workspace access, a vote in our OWASP Global Board elections. And recently, OWASP added a brand new member benefit, access to hands-on application security training through the OWASP Secure Flag Open Platform. Join us and become a member today.
Right. Okay, this worked. Now it's important for me not to play this video again. Happens all the time. Right. But hey, a technical meetup should have some technical difficulties, right? Okay, so here we are. OWASP is not only in London. These are all the chapters in the UK and Ireland. And if you are from another country, there should be an OWASP chapter near you. So if you're from abroad, just Google OWASP and the name of your country, name of your city, and you will find hopefully a chapter near you. If you don't have a chapter, feel free to start one. I know quite a few people traveled from quite far today to London to this event, but these are all the chapters that we currently have in the UK. As mentioned in the video, there are several benefits available if you join, which include Secure Flag, subs like Phoenix, there's a system called Ubik, security journey training, but there is also a code bashing system, which is a security training platform, which has lots of training courses available, which if you join OWASP will be available to you for free. Now the membership costs $50 a year for individuals, and at the current exchange rate, it's changed recently because of Trump and political situation, right? So I think it's about £38 at the moment per year. So again, it's less than the price of coffee a month. You will £3 a month. You can have membership to OWASP. Obviously, advantages also include things like having your email address and Google Workspace, access to our community. You also get discounts to many conferences because if you log in with your OWASP.org account, a lot of conferences such as RSA or Black Hat will give you a discount. If you're a student, you'll get a discount on your membership. It's $20 a year. And if you represent a company and your company would like to become a corporate supporter of OWASP, please do come and talk to me, because then we'll be able to help you to support OWASP globally. Now, to join, you can just go to owasp.org/membership. And there is one extra benefit, which is only available from me. If you join OWASP tonight as a member, I have an extra benefit available, which is not listed in the video, and that's OWASP member sticker using old OWASP logo. So it's a bit of a vintage sticker. So yeah, you can see it on my laptop as well. So that's the laptop sticker that you will get. And if you show me an email confirmation that you joined OWASP tonight. And obviously there's one more advantage, as I mentioned, is they can vote for OWASP board members. The election is going to be in September, October. I'm currently on the OWASP Global Board. So thanks everyone who voted for me last year. As mentioned in the video, OWASP is a vendor neutral community, but we are supported by sponsors, right? So there are lots of sponsors who are supporting us, and we thank all of them. Now, OWASP London has separate kind of list of sponsors. People are specifically supporting our chapter. And if you would like your name to appear on this list, please do come and speak to me. And can I just ask you all to thank the hosting venue tonight, this wonderful Zero Tech Junction, by a round of applause. And the sponsors of the pizza and drink, the food and drink, that's Endo Labs. So if you would like your logo to appear here and sponsor any of our future events, if you have an office space like this, please come and talk to us. If you don't have an office space like this and would like to hire this venue, then again, please do come and talk to us. For those of you who are members, we do have a brand new membership system called Glue Up. So you can, if you become a member, you can manage your membership through it. Actually, you will pay for a membership using it. There's one other advantage you can get. Apart from the physical sticker, you can also get a digital NFT sticker. So this is something that I started doing a couple of years ago. So it is your digital proof of attendance protocol NFT. For those of you who know what it is, if you don't know what it is, again, feel free to come and talk to me. I'll explain how it works. Instead of giving out your certificate of attendance, you get a badge or a coin or a sticker, or it previously used to work, right? But now you actually get it on the blockchain. So it will stay on blockchain forever, and you collect it in your wallet. So you can only get this NFT from me, and that's a proof that you attended tonight, this event in person, right? There's no other way to get this NFT. So there are different pictures for every single NFT. So you collect them all like Pokemon, right, in your wallet. But this is the one for tonight, right? Because may the force be with you. We give out a lightsaber, so we have our Darth Vader WASP tonight. So we have a merch store. So if you want to buy an OWASP t-shirt, baseball cap, or any other piece of merchandise, you can go to owas.org/store and buy a piece of merch supporting us as well, because part of the goes to OWASP as a donation. And literally next week, we have a big OWASP Global AppSec Europe conference in Barcelona. So I will be there. I'm speaking there, and I have to be there also as a board member. So I know at least 2 people who are attending from the audience. So yeah, awesome. And I think there is also a vendor attending and exhibiting there. So that is happening next week. OWASP usually runs 3 global conferences per year, one in Europe, one in Asia, and one in United States. There will be a Singapore conference in September, and there will be an OWASP Global AppSec conference in Washington, DC. And that will be in first week of November. Now, before I'm going to talk about DC, if you want to go to Barcelona, there's still a chance you can win a ticket. And the way to do it is we have a sponsor called Phoenix Security. And I said, if you comment under the LinkedIn post with your best joke relating to application security, AI, or vibe coding, they have a draw and you get a chance to win a ticket. So if you have a LinkedIn app on your phone and you just scan this QR code, it will take you straight to that post. And you will see some very interesting comments. People already put out on LinkedIn, desperately trying to get a free ticket. I think you still need to pay for your flight and hotel, but the actual conference ticket is free. Unfortunately, Francesco from Phoenix Security is not here because he's speaking at another event in Belgium tonight. But there you go. I did put up the announcement. If you are in cybersecurity, would like to share your knowledge with the community, and you would like to submit your talk to our Washington, DC conference, this goes to our current speakers for tonight as well. Please do submit your talk proposals. Call for papers is open. It's going to be open for another 3 or 4 weeks, I think. And then if your talk is selected, you'll get a chance to present it in America. Quickly about OWASP projects. So OWASP has over 250 free and open source projects. They cover all the different aspects of cybersecurity. We have projects called flagships. So there are top 20 projects here that you can see. There's the OWASP application security verification standards, Cyclone DX, Defend Dojo, JuShop. Probably some people use JuShop for the training, right? Lots of lab projects, incubator projects. And today we actually have a talk about a new project, which is great. One of the projects that I want to spotlight is OWASP Gen AI. So OWASP Gen AI is a brand new thing, and OWASP has actually done very well because we now have up and coming standards in AI security. We also have lots of guidelines, including this Gen AI red teaming as well. So and lots of other useful documents that you can get from our OWASP AI project. Now, because there are so many of you today and there are people watching online, if you have a question to the speakers, please use the Slido system. You can just open your phone, go to slido.do/OWASP or slido.com/OWASP, and you will be able to ask your questions. So please keep your questions until the end of the talk. And now I'm going to introduce Henrik, who's going to talk to us about attacks on open source supply chains and how hackers poison the world. Let's all welcome Henrik. Right, I'm going to stop sharing and make if you share. Awesome, that's working.
All right, you hear me well? No, no.
That's one. It's all right.
That's on. All right. So yeah, hello everybody. Good evening. Thanks for joining. My name is Henrik. I'm from Endor Labs, and I will talk about attacks on open source supply chains. So we all use open source, a bunch of open source, but unfortunately, a couple of years back, attackers kind of discovered this as a viable means to inject malicious code into your supply chains. And what I will talk about in the next 45 minutes is I will provide you a lot of examples on actual attacks or vulnerabilities that could have led to an attack, or just proof of concepts showing you all the different attack vectors. I will then provide a more systemized or systematic overview about those attack vectors. And then at the very end, I will briefly touch upon a couple of safeguards. Here again, the QR code for the lightsaber, just in case you didn't have enough time to catch it earlier on. I will print it once more. It's really a great gimmick. Before I, no, I was that. Okay, that's not working anymore. That's fine. All right, so just one slide about Endor Labs, really quick. We are a small startup, 3 years old, offering all kind of security services around software development. So we have a knapsack platform offering secret scanning, container scanning, first-party code scanning. But what we started with, and what is still kind of at the heart of our platform, is this program analysis technology, which where we actually have a lot of detailed code level information about the first party code, as well as about all the dependencies that we pull into our application. So on the left-hand side, you see just a random application, right? First party code, this is the stuff that you write. And then you have a bunch of direct dependencies that pull in transitive dependencies and so forth. This goes in the hundreds. You all know this, supposedly. And in normal or many kind of solutions, they kind of put labels, vulnerability labels, just on the boxes, just on the packages. And this results in a lot of findings generated for your applications. And what we do, using this code level information, we try to understand which of those packages and which of those functions inside those packages are really used in your application by your first-party code in order to reduce the vulnerabilities, the alerts to those that really matter in the context of your application. Real quick about me. So I'm a security researcher at Endor Labs. I started working on this whole topic of open source security around about 10 years ago. And my main interests are the detection, assessment, and mitigation of known open source vulnerabilities, right? That is exactly the topic I was mentioning on the previous slide. I'm the co-author of 2 open source projects. One is Eclipse Steady. So this has been given to the Eclipse Foundation at some point in time. It's this function level reachability solution just for Java. And the other one, Project KB, is a data set of fixed commits for vulnerabilities in open source solutions. So this is contains a couple of thousands of fixed commits for a couple of thousands of vulnerabilities, and that is useful input for researchers in order to develop these program analysis solutions. The second topic, and that is the topic of my talk, is looking into the classification and detection of supply chain attacks. Again, I'm the co-author of 2 open source projects here. One is Backstabber's Knife Collection, That is a data set that we have created in 2020 together with the researchers from the University of Bonn in Germany. It's a collection of malicious packages that have been used in real-world attacks. Again, this is a data set helpful to develop detective controls. And the Risk Explorer, which is kind of a visual tool to explore all the possible attack vectors. I'm going to show a quick demo later on. So when we talk about software supply chains, we have to talk about open source. But just to make one thing clear, this is not in no means a criticism or critique of open source software, right? We all rely on it. I rely on it. Endor Labs, you all. So I just wanted to put this straight in the beginning. Good. This is the picture I've shown you in some other form earlier on. So on the top, you have your first-party code, and then this layer, dozens, hundreds of open source dependencies. Here we have some statistics, how this looks like. So almost all of the software products include open source software. And those that include open source, the share of the overall code base is going up to 76, 80%, depending on the studies. Here, this is some statistics done, taken from a paper that I co-authored a couple of years back, showing different, characteristics of how those dependency graphs look like. So in those, across a couple of thousand Java projects at SAP, we had like 21% of those dependencies were direct dependencies, close to 79 were indirect dependencies. Here we distinguished the scope of those dependencies. 58% were compile time dependencies. So these were dependencies that your first-party code required to be present in the class path in order to compile your application. And then we have 17% test scope dependencies provided, or system scope. So this different kind of scopes, this is existing in similar ways also in other ecosystems, right? NPM, for example, just distinguishes developer dependencies and then the other dependencies. What is important here, not all of them go into your production code. A test dependency, of course, is only present while you run your tests on your laptop or in your CI/CD system. So this is one way of an easy way to get rid of false positive alerts if you figure out this is just a test dependency. And here the last part is around how many of the dependencies of those applications were actually open source. Well, 86%, and just 14% were in-house dependencies developed by the same company. So these were a couple of numbers in terms of number of packages and the share of the packages. This is a different perspective. Here we count contributors, and I'm not sure whether you can read it really well. That is a screenshot taken from GitHub a couple of years back. They don't have this functionality any longer, but I find it very speaking as to how much you depend on all those upstream guys. So we don't count packages, we count contributors. This is the repository of Eclipse Steady, the thing I was mentioning earlier on. We had 9 colleagues, me included, working on the stuff, making commits on that repository. And there are 22,223 contributors to the upstream repository, which is just a crazy high number, which I find very speaking. I don't know why they removed this. I really like that feature, and luckily I took a screenshot. Another way to look at this is in terms of money. So here, this is some numbers published by the Harvard Business School in 2024. They estimated the so-called supply side value of open source at 1.22 billion to 6.22 billion. Supply side value of open source means that if all the open source that is out there would be redeveloped, this is how much money we would need to spend. And the demand side value is estimated at 2.59 trillion to 13 trillion. Crazy numbers. Demand side value means if nobody would use open source at all, but everybody would just develop this functionality all in-house. Good. Now that you know, I mean, you knew already, but have some additional numbers maybe. starting 2018, 17, 18, I would say, attackers started to kind of exploit and misuse this whole open source based software development culture that we have built in the last 20 years or so, right? So they try to find ways to sneak malicious code in the packages that you pull at different times into your software development, be it on your developer laptop, be it in the CI/CD system. Supply chain attacks themselves, they're nothing new, right? So that term existed already before, but originally it was meant to kind of compromise the download servers or the vendor's infrastructure, so where people would download, you know, a new version of some commercial solution. Right? A good prominent example is NotPetya. That was a supply chain attack in 2017, if I'm not mistaken. NotPetya. This was on a Ukrainian bookkeeping software. And so people downloaded an infected malicious version of update of this bookkeeping software. And from the Ukraine, it basically spread across the whole globe. There were a lot of victims. One I still remember is, I think, a container ship logistics company from Denmark, Maersk. And I think it hit them to an extent that they were managing their fleet of container ships by paper. And then, as I said, in 2017, attackers started to also look more closely at open source software and ways to sneak in malicious code. What is important here, and the picture is maybe a little bit too overcomplicated for the message I want to pass. One important difference between supply chain attacks and the problem of known vulnerabilities in your open source dependencies. If you talk about these, vulnerable open source dependencies, what really matters is what goes into your production code, right? So imagine you have here an application A with a direct and indirect compile time dependency. This is what is running live, what goes into production. And so if you have a vulnerability, of course, you need to fix it. But if you have a vulnerability here, well, it doesn't matter much. It runs in your, test environment, for example. For supply chain attacks, all those scopes matter much more because, of course, an infected test dependency could also, do some damage, could exfiltrate your, secrets, GitHub tokens, AWS tokens, what have you. So that is an important difference between those two topics, let's say. Open source supply chain attacks. Here we have some screenshots showing just how many malicious packages are kind of published on registries like NPM or PyPI or Maven Central, even though most of those attacks happen on NPM and PyPI in the past. Other ecosystems are not as badly affected, at least not in terms of numbers. These numbers may be a little bit inflated. I don't really know how they count, right? Do they count packages or package versions? And I don't really know. What is without doubt is that there is a steep increase of supply chain attacks. And those range from very simple ones, mass-produced, automated ones, all those typo squatting attacks, to very targeted and very resource-intense attacks like this attack beginning of last year on XZUtils, right? Where the people spent kind of 2 years to build up credible developer profiles up until they got granted the necessary write permissions on the repository and sneak in malicious code. Now I will walk you through a couple of examples, starting back in 2017 and illustrating different attack vectors. The first one here is from 2017. This was about gathering weak NPM credentials. So here, this was not an attack. This was a proof of concept, a white hat hacker, if you want, trying to understand the dimension of the problem here. So what he was able to do is he kind of got access to the credentials of more than 17,000 accounts in NPM. 16,900 of those accounts published something, right? And those 16,900 accounts that published something amounted up to 14% of the packages published at that time on NPM. If you only consider what they published themselves, if you also consider other NPM packages that depended on those, this guy would have had access and to impact, to influence more than half of the NPM system ecosystem at that time. Here are a couple of quotes of how, showing how kind of little awareness existed among the maintainers on good password practices. Great news here is that by now, two-factor authentication is required for maintainers of popular packages on NPM, on PyPI. There was a little bit of an argument going on from some maintainers, but I would say all in all that it was a very good development. And so this thing is not possible anymore like it was a couple of years back. This one here, I like, I kept this just because I'm speaking here in London. It was one of the earlier typo squatting attacks, and they took benefit from the fact that you write colorama or color a little bit different than our friends from the US. So the legit package was colorama with just with an O, and then the typo squatting attack was basically colorama with a U, like you spell it. What it does is it downloaded. So when you installed the tarball, it had a setup.py file, which is then executed. And what it did is it basically downloaded a Visual Basic script that contained then a clipboard hijacker in order to steal your cryptocurrency addresses. How do these work? They basically observe those malicious packages. They observe the clipboard. And if you copy something that looks like a crypto address, it would get it and exfiltrate it to the attacker. This one got persisted and in order to make sure it's always running. The characteristic of this is like kind of a blueprint of the thousands and thousands of packages of that kind that you find on NPM. So you always have this, again, you're not really able to read this so well, I suppose, but you had a large base64 encoded string. And so that in order to, obfuscate it a little bit, make detection a little bit more difficult maybe. And and you would just decode this, execute it, download the stuff and execute it. It's just like 10 lines of code. And that is how still, I would say, the majority of the malicious packages look like. Very often, you can see it just as a new way to deliver standard malicious stuff. So rather than only attaching this to emails, right? This is another distribution channel for the same thing. This one here hit the, let's say, IT news quite a bit. End of 2018, this was a successful attack on Event Stream. Pretty often used. So it had 1.5 million downloads per week, a lot of dependent packages. The thing here is that the attacker basically was granted write access or even ownership of this repository because the original developer of that package has lost interest in maintaining it. And so once he got access, he basically added a dependency to event stream. And that dependency, which was called flatmap, where is it? Flatmap stream, I think. Flatmap stream, there it is. That contained the malicious code. What was interesting about this one is that the malicious code did not trigger in the context of all downstream dependents, but it only triggered in the CI/CD systems of one downstream user, namely the Bitcoin wallet copay. And only in that case, it would alter the code of this Bitcoin wallet in a way that it monkey patched, it overrode the functionality of a function called credentials.keys, get keys. And the change was that once that thing is called, it exfiltrated again wallet credentials. And as so many times, we just discovered this, or the community just discovered this by luck, just because the malicious code contained one deprecated command, and somebody paying attention to those logs passing by when building stuff. He noticed this and dug deeper until he eventually found it. Also very well known, maybe rings a bell for many of you, dependency confusion. That was found by Alex Birsan. And what he noticed is that thing here on the right. He basically looked at dependencies of applications, and he noticed that those dependencies here, they are not available on any public registries. And so he concluded, maybe these are internal dependencies. And then he had the idea of publishing packages with the exact same name on the public registry. And he could do this without any problem because it didn't exist, right? He could just deploy it. And then he was exploiting the fact that the dependency resolution process of package managers like NPM and PyPI, and I think there were also a couple of internal registries affected, when they are contacted or when they are asked to resolve a dependency, the vulnerability was that they preferred a public package with a higher version number over the internal packages. And so it was eventually just a vulnerability in the dependency resolution process of those package managers. That made quite some wave, and it still does. This is still a thing. Interestingly, this is mostly affecting bigger corporations, those that have internal packages, right? So the small startups that do not have all this infrastructure, they don't have internal registries. They kind of escaped this guy, Alex Birsan. Yeah, very nice finding. I think he earned a bunch of money with the bug bounties with this. A couple of years later, this is March 2021, an attempted attack on PHP. So this luckily didn't work out. There were two malicious commits noticed in the source code repository of PHP itself. And kind of commit message pretended to fix some typos, but in fact what it did is it injected a backdoor that for a given HTTP header, it would extract a substring from the header and would run this command on the server running this infected PHP server. And that is a testimony of the kind of rigor and the quality of open source communities. This thing was just spotted a few hours later as part of routine post-commit code reviews. That is amazing. That is still, just great to see how open source communities react swiftly to those kind of incidents. If it had reached production, maybe you have thought PHP, what does he want? Well, why PHP? Does it really matter? Well, it does. This is statistics from 2021. PHP is used by many websites. This is probably due to, these typical content management systems. And this is still the case. So this is a screenshot of the same page, statistics from February 2025. So PHP is still a thing. So this would have had, far-fetched or far-lasting consequences. Problem here was the PHP guys, they operated their own Git server with some supposedly insecure configuration, which eventually led to this attack. By now, they have moved their code base to GitHub. Just a month later, I noticed, right now, there was another vulnerability in PHP Composer. So this was not an attack, but this could have led to an attack if it had been discovered by a malicious guy. Composer is the package manager for PHP. This thing is also running on the registry, which is called packages.org. And that vulnerability would have allowed, with plenty of download requests. And so that could have allowed an attacker to actually not only tamper with a single package, but to tamper with all the packages that are stored on packages.org. To the best of their knowledge, the vulnerability has not been exploited. Time did I actually? Yeah, good. Yeah, you don't know how many slides I still have. All right, but I like the examples. I think they make it very, clear, and they are very illustrative of how attackers can, sneak the code into the supply chain. This one is very interesting. It's about Unicode encodings. And so here, Unicode allows, they have something which they call BD, control characters. BD means bidirectional characters. This is to support languages that are written from left to right and from right to left. And what the guy here found is that you could use them in a way that what you would see in an editor or on GitHub when you review your pull request is different from what the compiler or the interpreter actually executes. So here you have something, a very simple kind of dummy example, where you have here a condition checking for the access level of the user. So you have here the condition followed by a comment, right? This is what you see or what you saw on GitHub. Now, but what is actually kind of existing, and here you see in red and blue the BD control characters, the actual condition is looking different. And so this sounds, and so this is what the interpreter would actually execute. And so this is a little bit of a toy example, but it is imaginable to conduct an attack, right? Following up, GitHub added this small exclamation mark. Maybe you have, if you see it. So this is just to say, here are some special Unicode characters in your code. So maybe look more closely. This also affected Visual Studio Code and a couple of other IDEs. I think I should hurry up a little bit. No, this is also interesting. NPM. This was a vulnerability again. The root cause of this problem were inconsistent authorization checks. So if you uploaded a package to NPM, if you wanted to publish something, the vulnerability was actually that the access control checks were done against the package as identified in the URL. But the actual package name was also consisting in the payload of your post request. And so you were checked against one package, but what you have deployed was something completely different. Again, to the best of their knowledge, it has not been exploited, but the logs only lasted until September 2020. Now we are getting closer to today. But I think I will skip this. I will rather go a little bit more in detail on what you have heard a couple of weeks back, which is TJ Actions. And that is actually, so it made quite some waves also. So here there was some malicious code added to a JavaScript file of this GitHub action, right? And so if you happened to use this GitHub action directly or indirectly, this script or this piece of code would actually dump the memory of the runner, which is containing the secrets of your repository, and it would print it to the log. Interestingly, it only printed it. It didn't exfiltrate it. Would have been much easier for the guy to collect the stuff. I don't know why they did it like this. Maybe to stay under the radar in order to prevent kind of more suspicious network calls. How did they get into this? Well, the commit that introduced this malicious code was actually impersonating renovate bot. And this is really, impersonating GitHub commits or Git commits is quite easy. It's just a matter of changing the configuration setting. You put the email address of the guy that you want to impersonate, and then in the GitHub UI on the web, it looks as if it has been done by that guy. The attacker added this commit to a fork of the legitimate renovate bot, and the repository was configured in such a way that in a pull request of the legitimate renovate bot, and the repository was configured to merge those pull requests automatically. This is how kind of sneaked it in. And then you also changed the tags of the TJ actions to point to this malicious commit, right? And I will come to this in a second. First, he changed it he only changed the tag of one version, namely one that was used by Coinbase AgentKit, yet another crypto technology. And then later on, he changed all the tags of TJ Actions. The impact of all that was that the workflow secrets of all direct and indirect users of changed files, there were 23,000 or so, get locked if they executed the workflow during the time of that compromise. And I will have some numbers on this later. Now, how did he get write access to TJ Actions? Right, I was just explaining what happened at TJ Actions. In order to get there, there was a sequence of attacks on other upstream repository, and all those upstream repositories, let's say, were involved or were kind of compromised through pull requests, in the same way changing tags, exfiltrating personal access tokens that eventually gave him a personal access token of a maintainer of TJ Actions in order to do the things I was mentioning in the first bullet point, or the first couple of bullet points. I really recommend reading through the write-up of this Palo Alto Network Unit 42. You have the link here. They did a great job in figuring this all out. There are a lot of takeaways for this one here, from signing commits, protecting your branches, to pinning your actions to commits. This is what is, which was, I think, a huge or maybe is still a misunderstanding of many GitHub Action users, that if you pin, if you just refer to a tag when you use a certain GitHub action, you actually, pin something that is mutable, that can be changed. So, right, you maybe think version 1 of that and that action is always the same thing. It is only the same thing as long as the tag stays the same. If an attacker changes the tag, your version 1 is just, using something completely different. That is why you should pin your actions to the commit hashes and not to version tags. GitHub has something in the making to overcome this deficiency. I hope they are going to release this soon. And then other kind of, avoid personal access tokens if there's no way around, restrict their permissions and the lifetime. Also avoid the pull request target trigger. So this is one trigger that starts a workflow, and that was at the root of all this chain of compromised repositories. Because the thing is that those are workflows that can be started also from forks. And as part of those workflows, you have access to the secrets of the repository that you forked, which is a huge problem, obviously. So those have to be used with a lot of care. And I'm not going into the last point. Right, so TJ Actions, I think the lessons learned, well, the takeaways I showed earlier on. But again, I must say, I think we got lucky. Okay, sorry. I'm used to waving my hands around, so that is not working well with me, Mike. So yeah, we got lucky. 23,000 downstream repositories used, depended in some way or directly or indirectly on TJ Actions, but only a smaller number got compromised, really, because the attack was discovered relatively quickly. So this is from a blog post I wrote a few days after the attack. I tried to understand, well, how many leaks got actually leaked? How bad was it? Was it really 23,000 repository? No, it weren't. So I found 5,400 something repositories that directly used it. So I just used the GitHub search in order to figure out which workflow files had TJ Actions. So this number is a bit smaller, but because it doesn't consider indirect dependencies, right? Then I looked how many of those repositories actually ran a workflow in the 24-hour time frame. Not so many, 640. And then how many secrets were actually leaked? Again, not so many, 218. Most of them were these GitHub tokens. Again, you can't read this. Those are short-lived. They live only as long as the workflow runs, or at most 24 hours or so. And then there were a couple of AWS tokens and other things. I notified, of course, the repository so they could delete their logs. So actual impact, not so much, but only it was so quickly discovered. I think it could have been much, much worse. Now, you have heard a lot of examples all across the place, very difficult to follow maybe. And so I would like to use a few slides in order to, bring some system into it, some order in it. And so again, as a quick reminder, you all know this. This is how the code flows from a versioning control system with contributors and maintainers to some build system where all the upstream dependencies are pulled during the build and the final artifact is published in the registries. And then the consumers, we can either build the stuff from the versioning control system, which virtually nobody does, or we just download the prepackaged stuff from registries like PyPI and NPM. Now, this is kind of showing all the different spots where the attackers, that the attackers considered, that they looked at in order to conduct their attack, or could have done if they were able, for example, to find vulnerabilities first. So just a few examples here. This Trojan source, right? The BD control character stuff. There was a problem with versioning control system and management platforms like GitHub in order to show those properly. And then we have here contributing as a maintainer, right? If you compromise a maintainer in one way or the other, you can actually change across the board, right? You can tamper with the artifacts of the project and the distribution system. You can configure the build system or change it whatsoever. Or for example, you create a name confusion where consumers then are confused in the name of the legit package and may download a wrong thing. So this is making this a little bit more structured. And what we did then is basically to create a taxonomy. And this is basically, so we have looked, and if I say we, this is research done by Pier Giorgio Ladisa and myself and a couple of other guys from the University of Rennes, where we basically reviewed hundreds and hundreds of white papers, attacks, all the stuff similar to what I've shown before in order to build this taxonomy. Again, you cannot read anything of this. The idea is this is it takes the form of an attack tree. At the top, the root node of the attack tree is the goal of the attacker to conduct a supply chain attack. And as you go down in the attack tree, you basically refine this goal to smaller goals that allow you reaching the top level goal, right? And the use cases of this is, of course, to raise and create awareness, to support threat modeling activities, but you could also use it to scope penetration tests. And so there was an interactive visualization of this thing, originally developed back then at SAP Security Research and forked at EndoLabs, and that is what I'm going to show you now. If I manage to change this. Yeah. So this is this Risk Explorer hosted here at EndoLabs, and you can now basically read this. You can explore this attack tree, right? So here's the top level goal. Then we have three sub goals. One is this create name confusion, and wherever you click, you basically open the sub nodes, and every node here comes with a description, a couple of references. References could be white papers, could be attacks, could be research papers, academic papers, and then on the right-hand side, you have a couple of safeguards, right? So this makes this whole thing a little bit more structured. It helps you understanding the problem space, right, and go to the respective resources, right? So here we, for example, we have this typo squatting. Also, this is the second branch here. It's all about naming confusion. Typo squatting is just one. Combo squatting, branch checking are just other similar techniques. Branch checking, for example, if you see a package that starts with AWS dash, you might think it's coming from Amazon. And so you may think and trust it more if it didn't start that way. And then here in the lower branch, you have basically the biggest number of attacks. Here we find the dependency confusion, we find techniques compromising CI/CD systems such as cache poisoning and so forth. All right, now we go back to the presentation. Good. Now, how do we detect this? Well, there are three techniques that I would like to briefly touch upon. One is we look at metadata, and by metadata, I mean package name, I mean the account that published the package, how long does this account exist, what were his past contributions, which other packages were published with this account, you know, what are the publication times, do the publication times on a package of NPM correspond to the typical daytime publication packages, or maybe they're suddenly done in a time zone at a time that is uncommon. Well, this is evaded by attackers through the creation of credible accounts and creating a package history, maybe creating a package that has a legit reason, a legit raison d'etre, and then only at a later point in time to add malicious code. The other one is static methods in order to detect malicious code. So here you would again use program analysis techniques, maybe look at API calls, you maybe build a call graph, these kind of things. You search for obfuscated strings, high entropy strings, these things. And they are basically can be evaded, for example, by splitting the payloads. I have a nice example later on, dynamic calls. So the attacker just puts everything in a big eval and as such escapes static analysis. And the last here is a dynamic, so kind of detection, where you run the stuff and then you try to see whether it does anything malicious. These are kind of these behavioral approaches to malware detection. Again, nothing new. A great project in this context is the OpenSSF project Package Analysis. They go great lengths in order to trigger as much code as possible of a package uploaded to PyPI, for example, so they observe any behavior. Unfortunately, this can be relatively easily avoided by just delaying or conditioning your execution, right? If you just wait 5 minutes before you execute malicious code, nobody running these sandboxes can pay the money in order to do this for thousands and thousands of packages. Right, this is a nice example for, well, nice, I keep on saying nice. It's all of that is not nice, obviously. It's, let's say, interesting. So if I say a nice, I mean interesting. This is an interesting example of malicious packages that I found. This was in 2023. And this, what made it interesting is that the malicious payload was split across different packages. So in order for the malicious functionality to work, both of those packages had to be present in the dependency graph of a victim project. It was downloaded a couple of times until we, told PyPI to remove it, which they did very promptly as always. So the one package was called Easy. It was basically an SQL query in order to find cookies in the SQLite database of Chrome. And if they found cookies, it would exfiltrate them in order to impersonate the Instagram user to whom this cookie belongs. And the other package, well, actually, the exfiltration was done in this other package, TTLO, which called a functionality of the previous one in order to obtain the cookies. And so that was interesting. Again, both of them had to be present. Still, I didn't manage to figure out how the attacker made sure that both of the packages are present in the victim package, because one didn't depend on the other. So that is a little bit unclear. I'm not sure, maybe they were just still in the making. If you look at these malicious packages, you see they publish a couple of kind of development versions until they reach a version that really does any harm and that works properly. You will be surprised how many easy development mistakes and bugs are contained in these packages as well. So here, this evasion technique was the split. And so what was interesting is the split was between packages, but also it used functions from different files. And so many of the more simple code scanners, they are limited in kind of the context that they look at. So they can only look at a given functions code, or maybe the code of an entire file. But by splitting the payload across multiple files, it's more difficult. So you would need, in this case, interprocedural data flow analysis. You would need to understand how does the data flow between functions of different files within the package to understand what's going on. To understand that a base 64 encoded string from one file is flowing into the decode function in another file. And then again here, this is what I mentioned, separate packages. So here you need whole program analysis. In order to find the complete malicious behavior, you would need to analyze all packages together, which is again beyond the scope of many scanners. Last, two or three slides to go. Selected safeguards. I mean, this space is so big. There are so many attack vectors, as you have seen with the examples and the systematization. I cannot really talk about all. So I just picked a few that I thought are noteworthy. But this is really a very subjective selection. Some of them are relatively cheap. Others are $3. So one is, let's start here. Remove bloated dependencies. I think this is where we have the biggest potential, because we pull in all those packages, but we do not use all of them. Some of them are just lingering around, they get installed, but we do not touch a single function. Let's try to remove those. A bit more complicated are those cases where maybe we use a subset of the functionality. Here you could imagine we basically rewrite the open source package to only contain what is really reused. This is exactly how it is done in Go, where you build your Go binary, great. But that is, I think, the only example I can come up with quickly. In NPM and Java and PyPI, you always pull everything, you always install everything. So this whole topic, there's a lot of, let's say, potential for improving our supply chains, just reducing it to the code that you really need and not try to install and, pull everything. One thing that is this is more on the $3 side of this examples is build dependencies from sources. So you don't pull anything any longer from PyPI. You just clone the repository, build it yourself, store it in some internal registry. Obviously very expensive. This is how Google does it. And maybe bigger players predominantly, I would say. Very expensive, but very effective because it cuts off. You remember one of the previous pictures, all the attack vectors looking at the build systems and all at the registry on the right-hand side, you get rid of them in one shot. Again, expensive. Digest and version pinning. And I think this is something that I always hesitate because I talk both about known vulnerabilities in your open source dependencies. And so if you don't pin your dependency, there are chances that you automatically get the fixed, secure new version of that package is great. So that in that sense, if I take this head on, I would say don't pin in order to benefit from that. But of course, if you do this, you also automatically consume any malicious version, right? And so, and if I have this head on, I would maybe say pin it rather than not. My approach is I pin, but then I have some automation in place to remind me of there are some vulnerabilities and help me bumping the version. But this is also very ecosystem specific. So there was recently a research paper that I didn't put in the references here. Maybe I can do this before I share the slides. There was a study on NPM dependencies and the question, pinning or not, what is better? And it turned out that if you pin your direct dependencies, you ended up with more versions of your packages than if you didn't pin it, which is because you kind of constrained the version resolution in such a way that it copied multiple versions of the end package in your node modules folder. So it's very peculiar. You need to look at this from ecosystem context to context. And then again, we talked about GitHub Actions earlier on. Here you should pin it to the hash, please. Two other kind of safeguards here. One is to isolate build jobs and build steps. Isolating build jobs basically means you run every build on a clean slate. You do not share any resources across different builds, because that gives room to cache poisoning attacks. You have your one build, and this guy maybe changes your local M2 folder with where you have all your cached Java artifacts, and those will be used by the next build of the same project or a build of another project running on the same machine. But this is even true, in my mind, for build steps. So if you again think Maven projects, you have different steps from compiling to testing to integration tests to packaging to deploying. And the thing is that in your typical POM file, you have plenty of plugins doing all sorts of things, generating code, generating documentation, running the test, and so forth. And the thing is, all those plugins have the same permissions on the artifacts produced during the build. So your test plugin has write access to the classes that have been compiled earlier on. They can tamper with the bytecode, which should not be the case. But I don't know of any kind of ecosystem isolating build steps. But I think this would be something to look into it. And for the same reason, what I just said, you should minimize your release jobs. So those build jobs that produce the artifact that you will use in production, that you publish somewhere, they should run with the smallest amount possible of plugins or extensions. So good. Second to last slide. Not sure how I'm in time, really. As always, I didn't pay much attention and just talked. So, perfect. Name confusion attacks, well, live with those attacks. They will never go away. They exist in any platform, in any marketplace that people look at and people download stuff from. It's just so easy to conduct. It doesn't cost the attackers much to copy malicious code, give it another name, upload, live with it, and get used to it like you got used to spam, right? The other thing is, what I think, if I may make a prediction, what we see going forward is more a compromise of legitimate packages. So where people try to social engineer themselves into the source code, into the repository, and inject malicious code, into the sources. One technique that could be useful in this context is this kind of impersonation of users, like this Dependabot impersonation you have seen in TJ Actions. They impersonated Renovate, another bot, and people just looking at the names may think they come from this legit bots. And sometimes they don't, right? And what I'm personally most afraid of are these deliberate vulnerabilities, right? So what I mean by deliberate vulnerabilities is code that if you see it, doesn't, let me start differently. For all these typo squatting attacks, if you see some base 64 encoded string and a setup.py, well, you know there's something fishy going on. A deliberate vulnerability is something that is not obvious. This is maybe a missing authorization check or a wrong authorization check, or maybe a regular expression that is off. Good luck recognizing such regular expressions. And an example for this is the attack from 2003 on Linux. This was a malicious commit, and what made it malicious was actually a one-character difference. So here, what happens at the end of this condition, here we don't check whether the current user is root, because if we wanted to check, we would have two equal signs, but we actually make the current user root. And so this would be a good example of a deliberate vulnerability. Back in 2003, it didn't make it in the kernel, luckily. That's it. Again, for the That's the lightsaber, and if you do not only want to have one, but also be able to use one, you can also scan this other QR code. Because what we did is we basically offer a stunt training session with a Hollywood stunt trainer so you can properly use it. So for that, scan, and yeah, we will reach out once this is going to happen in London.
We have lots of questions online about this stuff. One question online, questions from the audience. Question online was, any updates on when Dependable will support scanning actions that are referenced by commit actions? Updating all this manually is a pain.
No, I don't have any insights into what GitHub security is planning to do with Dependable. No, I'm afraid. But I must say, the pain of doing this. Oh no. No, I completely agree. That is a painful exercise, maintaining this and doing this yourself. I also have to do it. I hate it a lot. Maybe the good news is it's actually easy to detect, because unlike problems in source code, the structure of those YAML files, which you use for defining your actions, make it very easily accessible to code scanners. But again, I don't have a good solution to automate this, I'm afraid.
Questions from the audience? Yeah.
Should not be too difficult.
My question is about dependency, usually in the fusion and GitHub actions. With the source. What do you think is applicable mainly the fusion for GitHub actions? For example, you have private GitHub deployment, you have reusable GitHub action, private deployment, and somebody malicious creates public GitHub action with the same name, and in this way you can compromise your pipeline. But what do you think is applicable?
Yeah, that's a very good question. I think you just give me an idea what to try out. Now I don't have a good answer myself right now, but I think it's a worthwhile direction to investigate. Thank you.
No more questions? Okay, then let's thank Henrik, and we're going to go into 10-minute break, and then don't go anywhere, because we also have a next talk about open source intelligence. Thanks, Henrik.
I'm not a microphone guy, so I'm not sure how much you.
This will work.
This will work. Okay. Nice. Hope you liked it.
Yeah, thank you very much. Please don't forget to email it.
I just wanted to say hello. It's nice to meet you. Nice to meet you. My name's Rebecca. I'm from Skill Code Warrior.
Awesome.
From the customer perspective. It's my first time joining.
Oh, wonderful. Well, your colleagues have been supporting us for the past 9 years.
Exactly. And I was thinking to myself, we need to get a bigger logo on the screen, which means we need to do more with you guys.
That's right.
Yeah. My colleague Ethan on the back here has been a few times. Is this a must?
So, is Ilana still around?
Yes.
Yeah. Well, we've been working with Ilana for the past 9 years.
Can I take a picture and show her? I'll send it.
to speak. And second, well, can you just think it out? Just make sure it's perfectly. Right. Try this out. Yeah, this is fine. Ready for the next? Oh, next speaker. Learn about open source intelligence gathering. Okay, everyone. So this is a little bit of an interesting story, and I think the story will be useful to you. So Brenden approached me and said, "Sam, I've written this cool open source project which does open source intelligence, and checked it out. I was like, really, this is really cool stuff." But they said, "Can I just come to a OWASP meetup and like speak for 10 minutes about it?" And I'm like, well, the thing is, it's currently your personal open source project and your personal repo, and there are like thousands of people with open source projects. The value to the community will be if you actually bring it to OWASP, make it an OWASP project, and we actually are in the need to have an OWASP open source intelligence project, because we did have a few talks on it. By the way, if you check out OWASP London YouTube channel, you will find some talks on open source intelligence as well. This was really, really cool because they use AI and use some very interesting sources. And yeah, Brenden went through the process of registering it. So I actually asked you as well, if you have an open source project which you think will be useful to OWASP open source cybersecurity community, and you'll get support of the community, and you can come and speak about your project at OWASP events, meetups, and conferences worldwide. Yeah, that's something that you might want to consider. Please do come and speak to me, because I will tell you how to do it, and I can speak to Brenden as well, because he has gone through the process. He had a couple of hiccups, but we managed to overcome them. And now that is a brand new project. So let's all welcome Brenden.
Yeah.
Okay. Fine up.
So where do I go to share the screen?
On Zoom?
Yeah. Here. All right. So, okay. Is there a problem with
No, we'll
on the mic?
do you have the mic?
It's okay. Hi. Okay, well, thanks for that. Kind of like went over it. Say again?
Just mute your speaker in your life.
Yeah, I am. But yeah, it's locked down. I can't get to the volume easily. Okay, I think that should be all right now. All right. Okay, thanks. I'm Brenden. And like Sam said, I just came up with an idea and pitched it to him, and he said, sure, okay, let's do a little talk about it. So I've created a tool which is a bit of a mouthful, SocialOSINTLM. All right, and I'll get into that. Subtitle, fusing multi, whatever. It's meant to sound cool, but word salad. All right, so why I came up with this is, what does my online persona say about me? And then I thought, that doesn't really matter because I don't have an online persona anymore. I deleted everything. But then I thought, what can I find out about other people and what it says about them? And not just people, but businesses. There's a lot of information out there. So I created this tool, which is an aggregator and an analyzer. Okay, it just goes onto one of these social media platforms, pulls down data from a named user, and then analyzes that. I've created it so it uses OpenAI compatible APIs, so you can run it locally or through a hosted provider. Okay, so the power comes from fusing text and visual data. Now, this is important because you can scrape a social media platform or you can pull down a post, but you will lose information if you're just getting text. When you have images, that adds a lot of context and it can completely flip what the text means. So my tool will pull down the data and then uses a system prompt to submit that image to a vision model, and then gets the description from that vision model and puts it back into another system prompt, which then sends it off to the large language model for analysis and gives you this data back. I've structured it all to be grounded in what is verifiable rather than having it speculate on things. So it won't say it looks like it's somewhere. It will say these are the features around there. And this is a little bit of what it is. See, it's not speculating on anything. Semantic themes, settings, environments, yeah, potential geographical locations. And particularly important, it's not trying to guess who the person, if there is someone there, and concentrating on verifiable evidence only. And in my GitHub, you can see the two really big prompts for this. This is a little bit of the output from a JSON file, because it gets pulled down into JSON, and then that's JSON that gets submitted. Okay, and we can see here that this is a user I chose. We've got the setting and environment. Appears to be inside a mode of transportation, likely an airplane or train, based on what they can see. It's just a table seat, right? And they can see things like, and they can see the lighting suggests it's daytime. They see things like sunglasses on there, and the accompanying tweet. Actually, this is on Blue Sky. It says the beginning of a NITS project, and this is actually a US congressperson. This is what it is. So luckily, we here they're not leaking any data, but you can see there's a potential of them having something here, and then they have more data that gets ingested and output by the vision model that's got some notes on something potentially confidential. So when you launch a tool, it looks like this. You will effectively say, choose 1, 2, 3, 4, 5, 6. You can use commas to say, I want to say 1, 2, and that means you'll launch Blue Sky and Twitter. Or I've got cross-platform, which basically is the same as saying 1, 2, 3, 4, and 5. And this allows you to compare two different, not only that, is you can put two users, just separating them by a comma. So if I want to do 2 Twitter users, and I can compare them to each other and start analyzing data rather than just pulling down one lot of data, looking at it, which is generally what you'd have to do at the moment. And what I've chosen here is actually just the Financial Times, because I had trouble picking a person without it being a bit weird, really, because I couldn't think of a particular person to do this analysis of. So I went ahead and I chose Blue Sky for Financial Times and Twitter for FT. And I said, are they the same person or company? And so it's likely they are the two accounts. And then there's more stuff here, but it gives out the supporting evidence for this. All right. And then I went ahead and I did something similar. But this time I chose The Onion as a different one. Okay, so we all know The Onion is a satirical news site. And it says they are not the same because of this evidence, and there'll be a whole bunch more there at the end. But you can see that there's a benefit of that. For instance, if someone creates a Blue Sky account of like Coca-Cola, and then they start feeding data in there, that looks, it just points to crypto or something like that. This will easily be able to tell that they don't follow the same kind of patterns of posting. And this is just for companies. People who are involved with open source intelligence get commissioned to do things like this. Potentially, if one company is acquiring another, there'll be checks for this, and they'll go into a deep dive. It will also identify if other accounts have been detected in this, which can then lead you on another avenue. So, dear practitioner, okay, so if you're starting a new job, you may want to look into the company or charity or whatever it is that you're going to go to. Like I said, acquiring company could even be used for missing persons, because it will bring a timeline of an individual. Because it's got vision analysis, you'll be able to have things like, I'm going to the beach. It's text only, and if you're using a web scraper, but this uses the API, so it should be more reliable than a web scraper. So if you just say going to the beach, text only, what does that really mean? There are many beaches, but if you got a train ticket with of Brighton, that really narrows things down. Relationship matching, you know that there's different people that's getting called out in tweets and posts and things. And if you're red teaming, so you're doing some social engineering, you can really do a deep dive into individuals. And like the demonstration I showed earlier, it was information leakage. So I have the interactive mode, which is what I showed earlier, but it also has standard in using JSON, and this is my example. You don't need to use all of these. Here you can see I've chosen 2 Reddit accounts to interrogate, and then the prompt I want to put in along with the other system prompts. So it will submit the other strong system prompts along with yours, but you might want to focus on something like, say, show me only locations of this stuff. And then, like you saw, I put in, are these the same accounts? So that's the prompt you could put in there. And it allows you to make a bit of a easier pipeline. So if you're using tools like Sherlock to find common usernames on different platforms, if you know what Sherlock is. But it'll say, if you're like, you know the Twitter account, it will then search for the same user on many, many other sites. So you could do this target, put the user's account name in there, and then see, are they the same person, or it may lead you down some other path. There is a 24-hour cache on there. One, because posts get old, and there's no point in really analyzing old data. But the other one is, if someone deletes their account, we don't want that data anymore. There are terms of service in the APIs that are saying about right to be forgotten. So you need to respect that in a reasonable amount of time. You may not want the cache anymore. So there was an option to remove cache, either the downloaded analysis, the actual reports that are created, because they get automatically saved in Markdown, and images are also saved. So you can go back and refer to those that have come up in the posts. Okay, like I said, it's strictly on public available information. So it's not actually getting anything that you can't see by just browsing to the page or logging in. As I mentioned, the purge facility. This is important. A knowledge model bias, they can get things wrong and they can have biases and stay in the loop. You can't just let this tool make the decision for you because it's AI. It doesn't really know what it's doing. So that's my project. You can check it out on that GitHub, and thank you very much.
Great introduction and screenshots. Yeah, definitely go and check it out. It's quite fascinating, the stuff that you can find, and also thank you for sharing some of the interesting use cases for open source intelligence, which is quite relevant to us. I see a question here.
Hi, a great project, and so as I could see on screenshots, we could kind of interact with the tool. Is it in the plain text, like just we are giving a prompt to ChatGPT or AI tool? Is it similar to that, or we need to kind of get into a specific language or something?
So the whole strength of this is the two system prompts that it uses. It's not just pasting someone's tweet in there and doing a small bit of text saying, oh, please describe this. It's a whole bunch of text, and it's saying, only give me specific information, ground in evidence, tell me the evidence, don't make any kind of speculations, even though when you say negatives in AI, it can be ignored. And so I say, acknowledge that it's AI, and it can make mistakes.
Currently involved, which we have to provide extra. Now, the primary architecture starts with the Python script that has a lot of library, very powerful library, that basically does a splitting and generates a JSON file, which is then absorbed by both relational and non-relational systems for textual and semantic. For vector operation, because you may notice that some of the employees are going to the toilet to use ChatGPT for queries. When you ask them a question, can't answer, they just run. Use ChatGPT, which is not really nice. So what we then introduced here was the ability to have vector searches on inference systems. We created our own vector databases where searches were done using libraries into the vector database system that query the inference systems and inference engines. Topic, all of them there. Okay. Then they kind of train themselves. And when the questions were then asked, they give a structured response back rather than having a whole, because prompt engineering is quite terrible. It always gives you an answer, whether it's right or wrong. But when they use the approach we use, which might be a bit over the board, overkill, unlike yours, but it kind of produces a much more structured domain-specific response than just going directly to the LLM. The point I wanted to make is this. You do not make any reference to any primary programming language in which you educated or basically with a reference to the inference engine, LLM inference engine. You just said use an LLM, which confused me completely. Because I was expecting you to use a language library that basically made a reference to language whatever, for the inference system, the inference database, vector database, and a response back. But I didn't see that in.
Okay, so sorry it wasn't quite clear. Because I use the OpenAI API, you can use that against like OLAMA and any of the models there. Obviously, you need a good vision model. And I guess the strength is in the vision model and having the description of the text, because description of the image, because a lot can be lost if you don't have the description of the image to then feed into the other prompt. Sure, you can just have stuff where there's actually text and or posts and tweets with no images, and that's fine. And many you can scrape that and feed that into whatever system you have. But using the vision model to get the description of the image, which I posted up here of, that's just the JSON. If you go into the cache folder and look at the JSON for this particular post, it comes up with that. So I can actually look into this afterwards. You can, when you launch the tool, tap offline, and it'll only go and get data for accounts that you've already, sorry if I've been looking away from the mic, that you've already pulled the data down from. It ignores the 24-hour timeout on it. And then it will go ahead, still submit that against your LLM of choice and vision model of choice. And I've just been using Gemini for this. So the latest Google offerings, which are fairly solid. But you can choose any like LLM you want and vision model you want. So it's not calling any other Pythons. I made it look a bit fancy, so it's using rich and things like that, and I have little spinners in there just for the interactive part of it. If you want to use the standard in side of it, you still need those because it's part of the script. But that's it, kind of like, in essence, pulling down data into JSON, analyzing images that are associated with that data, and then being able to feed that in. Now, you talk about hallucinations. I don't think that's such a big deal anymore. And if it's hallucinations, it may be a word rather than the whole sentiment of something, because one of the analysis part of it is sentiment. Yeah.
Trained over the internet and does not have a specific response to a particular question, domain-specific question. It will hallucinate. It will bias. So what I thought was the best possible use was use libraries ordered from LangChain and LangFlow into the Python script itself to generate the JSON files. So when you're then targeting the inference engine to the Python database, it trains itself and say, oh, hang on, that guy knows what he's talking about. And it trains for a structured response, a domain-specific issue. That's the difference.
Sure.
Or like, basically,
well, it's MIT, so if you want to download it and work on it, that's fine.
We'll contribute to it, right? There's always a, for example, add LangChain libraries to it. That'd be great. I think we are out of time, so let's thank Brenden and
Okay.
let's move to the next step. Okay, the next speaker is Richard Tweed. Richard, have you joined? Okay, I just need to ask you to become a co-host. If you accept it, you will be able to share your screen. Right. And let me just stick a microphone on you for the YouTube viewers. Cool. Full screen. Wonderful. And let's all welcome Richard and his talk on the use of LLM for threat detection.
Good evening, folks. I'm glad Brenden has primed you folks pretty perfectly for most of the buzzwords that are in my talk. So thank you for meaning I don't have to explain them all. Who am I? I am a security and infra person at a startup just up the road. Before that, I ran and secured many banks. And now I work on generating software. So I'm here to tell you folks not how to do your jobs. I am here to give you folks a bit more of an idea of what's behind the curtain on a bunch of these tools. I'm trying to dispel some of the magic aura around large language models, some of the techniques around them, some of the terminology around them. And I'm also hoping to show you folks a technique that I've seen used in high-pressured incidents and also during really boring drudgery. And I'm hoping that that will, help you folks a bit more. So on that point, who here knows what retrieval augmented generation is? Not what it stands for, what it is. Okay, 3, 4 folks. Okay, who's using language models in their day job? Hands up, hands up, hands up. Keep them up. Now, how many of you are meant to be using them? Actually, don't answer that. But yes, so to that point, if anybody's wondering what you should consider before approving a language model, what types of language models to approve, happy to talk about that down the pub. That's not this talk. So with all of that out of the way, and my timer telling me I'm an hour 47 over, I've got a wee scenario for you folks to explain how you might use some of these techniques. So you're a security person and you've just found out that system that you use has a debug API if it was turned on in a specific month. And you're wanting to know, how vulnerable are you? How many of these machines are out there? Is this a thing where everyone needs to put down their tools? Every team needs to stop and scramble to fix this? Or is it a limited number? Things like this come up all of the time. So you're going to need to query, well, hopefully for the scenario, you've got an asset database. So you've got some level of inventory of what's actually under your control. And you're trying to work out, okay, am I affected? Am I not? If I am affected, how bad is it? So last time that you did something like this, it took you and your team hours because it's a new tool. You're not very familiar with the syntax. It's a weird flavor of SQL. And And on top of that, all of your old examples were for cloud vendor A, and this, the problem is actually over in cloud vendor B. I'm hoping this feels familiar to a few folks in the audience. This has happened to me far too many times. So you've got some tools, you've got your inventory system, you've got some runbooks for that other vendor, and you've got an approved language model. For this demo, all of this is going to be running on my laptop. Yes, it is a live demo. Yes, I am going to be cursed by the gods, but we're going to give it a go because this organization is very careful about their data privacy, about confidential information. As I said, my background is in banking systems. So I want to show you don't have to be sending all of your information over to another company that's perhaps domiciled on another continent, et cetera, et cetera. There are a lot of things that you can do with your own equipment. That does not mean they're as jazzy or as fast, but there's still a bunch of things that you can do. There are useful things you can do. So we've got the situation. We want to know how bad is the problem. Everyone's going to have a different approach for this. I'm sure a number of you in the audience are thinking, oh yeah, last time I did this, or I'm going to do this. I'm just going to show you one way. Again, you folks are the experts, particularly for your own fields. This is just another way of approaching that problem. Do what's best for you. So a lot of talk about large language models. Here's what they are. Souped up autocomplete. Glossing over a few details, but souped up autocomplete. So another term you might have heard is retrieval augmented generation. In fact, your tool is actually doing that. This is a technique for using large language models, and I'm going to give you an example of a cookbook. So you're wanting to know how to make banana bread, but you want it said like a pirate. So what are you going to do? You're going to send over the query of how do I make banana bread as a pirate, which I forgot to put in these slides, but we'll ignore that. And that's going to go over to what's commonly called a vector database. You can think of this as your cookbook. It's wanting to bring out things that are most relevant for your query. So it's going to bring out hopefully a recipe for banana bread, hopefully a recipe for rum, things like that. And it's going to send those back to the system, which then parcels all of that up, and it says user wants banana bread, said like a pirate. Here is a previous example of a recipe for some rum and for banana bread. That then all goes over to your language model and hopefully comes back with something sane. None of this technology is actually required, which is what I'm going to show you next. Does anybody have a quick question on this? Sam, did anything come in? So no, I've probably gone too quick. Okay, you're skipping to the demo. Yes, I will prove it to you. The question for online was, surely you need all of this infrastructure, and I'm saying no. The demo will show you don't need it. So we're going to, a little bit more information on the scenario. So we're back to the scenario. We have got a runbook for vendor orange. It's for the wrong time period. Vendor orange has a completely different data model because they're not virtual machines, they're instances. And other, fun and games, which just really trips you up in a high-pressured situation. It's the same sodding thing, but for reasons they have chosen to layer it up differently. So now what we're going to do is a live demo. And for that, I need Zoom to work with me. Yep. But before that, I need to make this small. Share the entire window. So what have we got here? On one side, that's fine. We'll be fine once we get started. Yeah. Okay. Thank you. You're going to get to see behind the curtain for this one. So we have our database on the left. We have a language model on the right. Thanks, all good. So for this, we are going to be using the Qwen 3 language model. This is released by Alibaba. It is an open weight model. What does that mean? It's like a binary you're allowed to monkey patch. They don't provide actual source data, but it's a lot more open than some other models. I have just chosen it because for my demo, it works. It's running on this laptop. I'm using a thing called Ollama, which was name checked earlier. You can use things like Jan.ai, which I spotted on Sam's desktop whenever he was sharing earlier. Use whatever you want. Kind of doesn't matter. They're all much of the same, open source. And in terms of the pretty UI I'm trying to use, I'm using a thing called Open Web UI. So what data have we got? So we have our, so this is the Cloud Asset Inventory System. Zoom is doing a wonderful job of reading it all, but that's fine. We have 173,425 virtual machine images, and we have 205,251 VMs. Going through this by hand is not going to work, not going to happen. I suspect a number of you have been in situations like this. This is not feasible to do by hand. The schema is a bit fiddly, a bit awful. It's some weird syntax. So this is SQLite 3, but again, all of these systems have their own thing. So we're going to go and ask our model a lot of stuff, which I will paste in. And while it does inference, I will explain what there is in the prompt. Yes, please. Thank you very much. So for this, Zoom isn't in the way. So structure of this prompt, I'm starting off by saying, using the information below, make me a SQL query for the SQL syntax that I'm using. I want it for these dates. I want it for the red vendor. And I want it to be affected virtual machine image up in the top right. Next, I'm saying only use things in the schemas below. This is not an anti-hallucinogenic thing for the models. It's more focusing in on these are database schemas. Like it's focusing the model. You're talking about database schemas. Give me SQL. Please don't leak which models these or which vendors these are supposed to be, because this is an agnostic demo. And here is the piece from my other run book already. And then after that, here are the SQL, here are the table schemas of the tables that you've got. To go back to our cookbook example, I've told the model, here's what I want. Here's one existing recipe, and here's how to do rum. Again, I didn't need a vector database. I didn't need some advanced tool to be able to like auto-magically pull this in or anything else. I can craft the whole thing by hand. And that's the key takeaway I want you folks to know. And this will work much better for giving you the output that you folks are looking for. These models are not all-knowing. They're not trained on everything. They don't know what's in your databases. They don't know what your teams are called. They don't know what your business units are called. They don't know what your priorities are because they're mauve and what that means. The way to think of working with these models is if I package this up as an email and sent it over to an expert in the field who doesn't work with me, could I get something useful back? That's the way to think of it. That's the way to think of your prompts. You probably are under-specifying what you want out of the model. So yeah, as you can see here, this is quite long. And the other thing, before I copy out the SQL and we find out whether this works, keep the message chains with the models focused. If you're doing one thing, do one thing per chat. If you start meandering, you're talking about different things, different tables, unrelated data, start again. You'll get much, much, much better performance out of the models. Now the moment you folks have been waiting for, let's run some SQL and see whether it detects our 112 vulnerable instances. Ta-da!
The thing is, if you're under government regulation, we're not allowed to use Alibaba.
Yeah. So just to repeat the question for online. Yeah, thanks, Sam. The question was, under government regulations, you may not be allowed to use Alibaba. The point is, I could have used, so this is running entirely on this laptop. In fact, the plan had been not to even be internet connected. This was meant to be an entirely offline device, but I need internet so I can send to Zoom so that all of Sam's incredible work pays off. This could be the IBM Granite models, which are entirely open data, open weights. It could be the Llama models from the US. It could be the European models. It could be that one model from the British company that went bankrupt. It could be whoever it is. Again, the quality will vary, but the point is, this is more about how to approach these problems rather than the specifics. So now that we have shown that it could work, let's do the sort of, follow-up investigation that we're going to do. So I'll scroll up on this. I have copied the wrong thing. I have copied my answer, not the question. So that the model is going to cheat now. So let's go back. Right, here we go. So what am I actually trying to do here? I am telling the model, I have all of this data. How can I find something suspicious? Which again is a common thing that you're going to do. If you're trying to come up with detections, you're going, I've got this flood of data coming in. What of it could be, and it's got stuck on. Okay, we'll try that again. This is pretty common for language models, and resend. Cool. While it thinks about it, yeah, so you're providing the model, what do you want to come out of here? And now it's doing something vaguely sensible here. So it's saying you might have weird machine types. If somebody's spinning up a Bitcoin miner, they're probably going to spin up a machine far larger than anything you normally use. So I'm going to take this query, probably delete some of it, and then let's see if it finds, and it found the suspicious attacker machine. So this is using, again, this font and zoom is not cooperating. What this has found is a machine that is running with a far larger instance size than anything else in the fleet. And it also is running in a zone that is not commonly used. And if I scroll down, and it is actually, yep, unusual zones or locations. So again, a common attacker approach is spin up infrastructure in a region that you don't use, because someone clicking around in the UI is never going to see it. So, okay, cool. The model has actually managed to find something, and it's found it through a bunch of the ways. Now let's do the other side of this that I'm hoping will get rid of a bit of judgery, which is, cool. That worked for the red vendor. Let's give it the database schema for the orange vendor and ask it to do those same anomaly detections. So I've primed the model. I've said, here we go. Here's a set of schemas. Here's the sort of thing I'm looking for. And now I'm saying, now that you've got all of that, give me the same thing, but for the other one. One example where you might come up with this is, say, for example, you're migrating from Kibana to Splunk, or you're going from Laceworks to Cloud Query, or Cloud Query to Wiz, or whatever else, and you've got these hundreds, thousands of runbooks. Migrating those is going to be pretty painful, but you can use techniques like this to speed it up. And again, the benefit would be that hopefully you've got sample data that you can then use to verify that these things are correct. Don't trust these. You will get hallucinations and all kinds of things. You have to test it. But if you're someone like me who isn't particularly comfortable writing SQL or weird SQL variants, it can at least speed up. Like, I can iterate on a query. I can't write a query from scratch. So with all of this, let's see if we got any weird machines over in Orange as well. So for this example, everything's in the US, and it has found some machines in US East 2. They look normal. So no, it hasn't managed to find the attacker machine. But again, it has given me a valid thing for what I'm looking for. And now this is where you can bring in your experience to go back in and say, right, I know for my fleet, we shouldn't have anything in the rest of the US, which should only be here, or it should only be these machines, or we tag everything with cost center. do the cost centers make sense? With that, we're out of the demo, and I will have a bit of a call to action if I can get Zoom out of the way. Here we go. So what do I think your next steps are going to be? And we'll just skip through these. I think you folks are going to be able to make new runbooks based on your old runbooks, and in this way sort of build them up. Another example where these sort of techniques come in, the language models are quite good at following patterns. So say, for example, you have one team that's making excellent runbooks, and you want all of your runbooks to look like those. Put in several examples of those and say, I've got this runbook, turn it into that style. They work much better with that, particularly with following patterns, which is why I'd prime this model with, here's an example of what I want you to do. Okay, you've generated some examples of what I want you to do yourself. Let's add to that. Let's add to that. I'm hoping you can also use these techniques to accelerate your investigation. So if you're in a time-pressured situation, you're able to use these to at least give you a starting point of like, oh, geez, it's awful o'clock in the morning. How am I going to detect an anomaly here? Give you some pointers there. It's more of a rubber duck than anything else. And you're going to find the language models are limited. As you saw, it got stuck on machine types. It was repeating off every single machine type that existed for that vendor. That's not very useful. Just stop it, cancel it again, throw something in that just says, don't do this instead. All right, so with that, here are the takeaways again. And here's some other resources you might want to look at. Here's some previous examples of converting between data types. And if you are interested in language model, Gen AI native kinds of tools, there is an open source project here, which is attempting to categorize all of these tools. So if you want to see, right, what security tools are using Gen AI, what documentation tools are using this, what testing frameworks, they're here. If you find anything that's missing, please add it. My company maintains this. And again, resources out there, given there's a flurry, Cambrian explosion of tools at the moment to try and work out what's useful for what. And with that, thank you very much.
Thank you very much, Richard, for a great demonstration. I have the first question, if I may. Your prompts seems to be very precisely written.
Yep.
The question is obviously that you obviously use some prompt engineering there. Yep. And how many sort of tries did you go through until you found the prompt which you think works the best? And obviously because you use Quen model, do you find that you need to adjust prompts for different models to achieve what you are trying to achieve?
Yeah. So second question first. You will have to tune your model, or you will have to tune your prompt. Sorry, you are recommended to follow the best practice of the model you're using. To give one example, OpenAI have trained their models to place a lot of focus on the start of any text that is provided to them. Anthropic focus on the end of any text that is given to them. So again, working out where to put the focus of your prompt is quite important based on model. Macy, one of my colleagues, did a talk around task framing, which is don't tell the model, like, I want to do this. By the way, I want to run it on a potato at the end. Rephrase the entire thing to like talk about the constraints of what you're trying to do. Like the whole way through, we're going, this is an asset inventory system. You're using SQL. You're a security person. We're trying to find these things out. To your first point around how much prompt tuning there was, the original version of this talk used Llama 3.0. I chose to use Quen last night because I felt like it, and it ran slightly better on this laptop. It probably took about 2 tries to get it to do roughly what I was wanting, and then about 6 more to make it deterministic enough to be worth risking for a talk. Generally, the challenge is if you're wanting it done in one shot, you need to put a lot more effort in if you want it to work first try, which I need for a demo. If there's an ongoing back and forth with the model, you can get away with fewer with like less precision. And again, if you're iterating on something like this, new conversations are your friend. Like if it can't get the SQL right, if it's just getting the table wrong, start again. Put the schema as a table rather than JSON, or JSON instead of a table, or whatever else. The main thing is short, punchy conversations, regardless of model. No model is good with long context.
No? Okay, let's thank Richard. Thank you very much. Right. Okay, at this point, I'm actually going to stop the live stream.